Hi, I'm Anoli, and welcome to Blender Bitstream. Today we're looking at hard surface retopology in Blender. Here we have our subdivided high poly model with just over 1.7 million polys. It has a high poly count because it's subdivided mesh with a detailed silhouette, which can be challenging when looking to retopologize to a low poly budget. We'll start by adding a cube, and then we can go through the detailing process. You'll notice straight away that when we make the cube 1 meter, we get z-fighting on the polys that share the same space. This can be used as a visual cue. When you're not checking if a poly is on the surface of the HD prop though, you might want to check this shading option called Retopology in the options menu. This will allow you to see just the mesh of the retopology object you're working on and can make things less cluttered. Once the base shape is in, I'll start using the cut and edge loop tools to define shapes in the mesh. Our main goal here is to get the same silhouette detail as the high poly mesh, but with greatly reduced poly count. Convex corners are especially important in making an object's silhouette appear to be detailed. Beveling some convex corners can go a long way, and help the object look just right from every angle. Concave internal corners with a smaller curve can be handled by the normal map and don't need to be beveled. The Extrude Along Normals tool can be used to extrude cut areas and flesh out details. It's important to start with the bigger details and work your way down to realizing smaller details. Our target triangle count for this object is going to be within Xbox 360 constraints, so we will limit how much smaller detail is modeled in, as the normal map will catch most of the fine details. Details that take priority are areas of the mesh that will need to parallax, like these insets on the base of the object. Of course, it will depend on your poly budget. If the limit is lean, then insets like this will have to be handled with the mapping alone. Don't worry too much about n-gons at this point. You mainly just want to get the shape as close as you can within the poly constraints that you have set. Also, I recommend you install the Loop Tools add-on, as flatten and spacing tools are super handy during this process. It's a free add-on and can really help save time. The link to the Blender extension page with the add-on is in the description. Once the main shape is defined, I start adding smaller details like these corner bevels. Once you have the shape right, I recommend you add a decimate modifier set to planar at 1 to 5 degrees. This will give you a clean slate to start defining polys and tris with once your surface is right. I've set the shape out and decimated, so now it's time to start cutting in polys. The goal here is to have no n-gons and no vertex that has more than 5 edges converging on it. I use custom-made scripts to check for n-gons and 6-point vertexes. These mesh rules ensure that there won't be any shading issues later on when baking the mesh, and are generally a good guide for making error-free 3D models. Here I'm using a cut tool technique to get 5-point vertexes around this double corner. This is a common issue, and this cut solution will serve you well in retopology. Now we have the faces and loops laid out, it's time to start removing polys to get under our 3000 try limit. This means we need about a 35% reduction in poly count. Using standard polygon reduction methods, I was able to get the mesh down to below 3000 triangles. Now the mesh is under budget and error-free, we can compare the silhouettes of the high poly and low poly models. Ideally, the low poly silhouette should match the high poly as closely as possible. I went ahead and UV unwrapped the low poly mesh. Once UVs are ready, the bake process can begin. Usually we use a cage mesh to bake, but for this object, we got better results with no cage. For an object this size, we set extrusion to 0.01 and the max ray distance to 0.03. Here you can see that even with a 99.9% reduction in geometry, the low poly model still preserves the silhouette and key surface details. Hopefully this gives you a faster, more reliable approach to hard surface mesh retopology, and if you'd like to support the channel, leave a like and subscribe for more Blender Bitstream. Thanks.